Hello, good day everyone, and welcome to our second lecture in AS 102A, Structural Design of Steel and Timber Structures. And for today, we will be focusing our session in discussing the use of structural steel as construction material. Kasi from our previous lecture, we already discussed how timber is used in construction. Now, we will try to understand why structural steel is also considered as a good structural material when we try to build our structures. Okay, so at the end of the session, here this will be our outcome and also the outline of our lecture. So we will be discussing some introduction on steel and then try to focus on the different types of structural steel, then the main properties that we are of concern, the stress strain curve or yung stress strain diagram na tinatawag natin. Then we will also outline yung mga standard cross-sectional shapes na ginagamit in practice and also will be used for the entire semester. Then kung paano siya basahin, we will try to discuss how to do that. And then last is to end it with the discussion of the advantages and disadvantages of the material as construction material. Okay, so at the end of the session, here's our goal: to discuss to you the use of structural steel in construction, to enumerate the types and classification of structural steel, to demonstrate the general behavior of steel under loading. Kasi yung sa stress strain curve, all steel, no? All structural steel almost behave the same, no? Kaya meron tayong discussion later on regarding that. And then lastly is to outline yung mga pros and cons man of the material. Okay? So let's start. So let's start off first with the term steel, no? So to understand better, we need to define first steel. So steel is an alloy made up of iron with typically a few tenths of a percent of carbon to improve its strength and fracture resistance. So ang main composition talaga ni steel is iron and carbon, no? And then yung term na structural steel, ginagamit natin siya for steels na ang main function is to carry yung load, no? To act as our main structural members or yung main resisting frame ng structure natin. Okay? So sila yung mga steel sections na ginagamit natin for withstanding yung mga possible loadings na ma-apply to sa structure natin. Kaya tatawag natin siyang structural steel. Now, going back dun sa composition ng steel, no? So it is mainly composed of iron and carbon, and then with some other element. Kaya nagkakameron ng iba't ibang classification or categories sa steel, no? So the structural steel is used in construction of different structures. So there are numerous varieties depending, as I've said, dun sa carbon content niya tsaka dun sa other chemical composition niya. So yung pag-vary ng composition dun sa mixture nung steel will affect yung mechanical property niya, especially yung strength, yung hardness, tsaka yung toughness niya. Okay? So there are also different shapes of structural steel depending on its cross-section. So an example of steel are as shown. So these are, siguro nakakita na kayo nito in person. So mainly composed siya ng iron and carbon with varying composition of chemicals, other chemicals, no? So let's go with the type of structural steel. So structural steel can be grouped according to their composition. So we can categorize it as plain carbon steel, low alloy steel, and high alloy or specialty steels. So when we say plain carbon steels, mostly iron and carbon lang siya with less than 1% carbon. So yun yung ano natin, no? Kaya siya plain carbon steel lang. And an example of this is itong first picture on the top, no? So yung top portion ng picture natin, that is what we are trying to um, show, no? Ayan. And then we have low alloy steel, so iron and carbon plus other component, usually less than 5%. So yung additional, yung pag-add ng component na yon, na-increase na yung strength, pero na babawasan nyo yung ductility niya. So later we will define ductility, pero yung ductility is yung characteristic o yung property ng material to retain yung deformation niya, o kaya niya mag-deflect nang hindi siya pumuputok o nasisira o nadadamage. So ibig sabihin kaya niyang maging flexible enough, no? So hindi iba siya sa flexible eh. Um, Kaya niyang ah, mag-possess, no, ng mag-carry ng load or mag-deform without breaking. Okay? Kaya yung ductility. Then we have yung high alloy or specialty steel. So similar daw siya ng low alloy steel, mas higher lang yung percentage ng component. Ibig sabihin, yung other chemicals natin. So, pag ganun yung nangyayari, nagkakameron siya ng other properties, no? Pwedeng i-increase yung resistance niya to corrosion, which is very prone sa steel, no? Especially when exposed sa air and water. Okay? So, yan yung groupings ng structural steel natin. Next, we can also identify structural steel depending on the structural grades set by yung tinatawag nating American Society for Testing and Materials, yung ASTM natin. So sila yung organization na nag-develop ng standard for us na malaman kung ano yung composition, property, and performance nung bawat structural steel na pwede natin gamitin in our practice, no? And one of the most common use structural steel, yung tinatawag nating mild steel na may designation na A36, no? Dito yung A36, yung 36 dyan pertains dun sa strength niya actually, no? Ibig sabihin niyan 36 KSI. Classified siya as plain carbon steel. So ito yung sample prop components daw niya, no? Approximately ito yung percentage niya. Meron siyang carbon, other than dun sa main component niya, no, na iron and then carbon, then meron siyang additional phosphorus tsaka sulfur. Okay? Then here, as you can see, a sample table na pinapakita yung mga properties na meron sa ASTM standard, no? So let's say kapag bawa ASTM A36 ang pinag-uusapan, naka-outline doon yung yield point niya, kung ano yung value na minimum, yung tensile strength niya, ano yung range ng tensile strength. Later, i-define natin yan kung ano yung tensile strength. Then, yung yield to tensile ratio na maximum, wala naman para dito sa plain carbon natin. And then, elongation niya in 8 inch. Dapat in minimum, dapat 20% lang yung elongation niya. Na very useful or important when determining the strain of our material, no? Then other commonly used structural steel are A572 for grade 50, no? Pag sinabing grade 50, so kanina, the A36 to 36 KSI siya. So grade 50, 50 KSI naman siya. So ibig sabihin ng KSI is kips per square inch, no? So unit of pressure, no? And then ASTM A992, which is also 50 KSI. Okay? So these two steels are very similar dun sa tensile properties daw niya, meaning itong dalawa. Ang ano lang is makita natin doon sa table, yung yield to tensile ratio niya, may limit yung para sa A992. Okay? So maybe dahil dun sa composition niya, siguro may slight different, may slight variance dito sa A572. That's why nagkameron na siya ng limit for the ratio ng yield and tensile strength. Okay? And then ito yung mga terms na binabanggit natin kanina na important for property of a steel, no? So pag sinabi natin yield stress, ito yung unit tensile stress at which the stress strain curve exhibit a well-defined increase in strain. Pero ano ibig sabihin nun? So without an increase in stress, so, later do sa stress strain diagram natin, mapapakita natin si yield stress. Pero when we talk about stress, we are pertaining dun sa, babalikan natin yung strength of materials nyo, no? Ano bang ang stress? Stress ay E over A, no? So, ang nagkakos ng stress is yung force, okay? Over an area na kung saan siya subjected, yung force na yun. So, ibig sabihin, sa stress strain curve later, we have a specimen na tinest. And then, para makuha yung behavior, yung curve natin, pinlat natin siya. And then, we tested it with varying loading. Then divide natin siya sa fixed or constant value ng area. And then, habang sinasubject natin siya sa stress, dun papasok yung tinatawag natin strain, no? Which is the change in length over the original length. So, ibig sabihin halimbawa, ang test na gagawin natin is tensile test, no? Ibig sabihin ng tensile is kailangan hinihila natin yung mismong material, halimbawa yung steel, no? So, we are using a tensile testing machine na pinupull yung specimen natin, yung steel specimen, away from yung both ends niya, away, no? Or in tensile motion or outward yung direction from the plane ng mismong nung mismong specimen natin. And then, mini-measure yung stress and strain niya. And then, yun yung pinaplat. Okay? And mamaya babalikan natin si yield stress kung nasan si yield stress. Then, we have the tensile strength. So, the largest unit stress that the material achieved in a tension test. So, meaning, ito na yung pinaka-ultimate tensile strength. No? Kaya, ang designation nito is FU. No? Dito, FY kasi ito yung yield stress niya. So, ibig sabihin, beyond dito sa yield stress na to, no? Ang mangyayari doon sa material natin is ano na siya, yung behavior na niya is nagpa-plastic na siya. Or ibig sabihin kahit hindi natin i-increase yung loading natin or kahit hindi natin increase yung loading, nagkakameron pa din siya ng deformation, no? So parang halimbawa 'di ba sa rubber band, meron tayong rubber band, when we try to pull yung rubber band, then as hard as we can, eventually mag-snap siya, no? So yung time na ano, na stretch mo yung rubber band and hindi na siya bumalik doon sa original na shape niya, nagni-near na siya doon sa yield stress niya. And then pag nakita nyo na medyo lumiliit na o parang nagka-crumble na yung surface ng rubber band, ibig sabihin malapit na siyang mag-yield, no? So, yun yun. And si tensile strength again is yung pinakamataas na stress na pwede na kayang i-possess ng ating material, kaya FU. Then we have the modulus of elasticity. Yun daw yung slope ng initial straight line portion ng stress strain diagram, or ito yung ratio ng stress over strain. Okay? So, E is equals to stress over strain. Okay? So, yan yung ratio ng dalawa. And we also have ductility, yung binabanggit natin kanina, is the ability of the material to undergo large inelastic deformation without fracture. Yan. Kahit mag-deform siya, pero hindi siya mag-fracture or mag-fail. Okay? Toughness is the ability ng material to absorb energy. And then, ibig sabihin nito, beyond nung yield stress natin, ito yung capacity ng material na tumanggap pa din ng loading, no? Before siya mag-failure. Okay? Then shear modulus is almost the same nung modulus of elasticity natin. Ang ano lang niya is shearing stress and shearing strain yung pinag-uusapan natin. Okay? Pero siya ay ano din siya? Ratio nung stress over strain. Okay? Ayan. So, to better understand these properties, pupunta natin sa stress strain diagram or curve, no? So, the characteristic of steel that are of the most interest for structural engineers or why you architects need to know this is dahil dito natin malalaman yung strength ng material natin, ng structural steel natin. By examining and plotting the result of a tensile test. Ito yung sinasabi kong tensile test, no? So that this is a tensile test setup na meron tayong steel specimen, then attach siya dito sa grip natin. And then as we apply yung load, dito may actuator, no? So may pull na mangyayari dito. So imagine nyo pag itong material na to pinul natin pataas, no? So encounter niya yung stress. Okay? Then eventually yung strain din na yung loading na ina-apply natin dito, we take that as P. And then yung stress strain values natin can be calculated na. Kasi nga, meron tayong load o yung P over A, yung area ng mismong specimen natin. Dito yung sample natin, syempre yung constant na area ang kino-consider natin. And then we have yung change in length or ibig sabihin kapag habang ina-apply natin yung loading, yung deformation niya over dun sa total length niya o yung original length niya. Yun yung strain natin. Sabihin, kung mabalikan yung strength of materials nyo, yung strain is unitless siya kasi it's the deformation per yung total length natin. Okay? And then ito yung sinasabi natin stress strain curve. So this is an example of stress strain curve of um, of most steel, no? So almost the same yung itsura niya pag tines, no? Yung mga plain carbon steel natin. Almost the same. So pag halimbawa mas iba yung component niya, medyo tumataas lang yung curve natin, no? Kung naging ganon. Pero experiencing the same scenario, no? Nakita mo yung mga points na yon. So, yan. So, halimbawa, magta-test tayo ng mismong um, specimen natin. So, once na nag-apply tayo ng load sa kanya, okay? So, once na nag-apply ng load, since meron tayong area, may stress na agad yon. So, kasi may P over A na tayo. So, meron tayo dito, stress. Then, nagkakameron din siya ng strain. Yung graph nun is itong point na to. No? Then papansin nyo itong portion na to is a straight line. Okay? So meaning, itong portion na to is anong nangyayari? Directly proportional sila. No? So ibig sabihin diyan sa portion na yan, pina-follow natin yung Hooke's law. No? Sabi ni Hooke's law na si stress is directly proportional kay strain. Okay? So, ibig sabihin yung increase in stress is same behavior nung increase in strain. Okay? Then, bakit represented siya by a straight line or a linear line, no? Meaning, yun nga, directly proportional siya, no? Na to a point na ma-reach na yung pinaka point na to, yung first point natin dito sa figure na to, yung first point, wherein yun yung tatawag natin proportional limit. So, ibig sabihin, pag lumampas pa siya dito, hindi na valid si Hooke's law, no? Hindi na hindi na directly proportional yung dalawa. Okay? So, after some time, may konti portion dito na magiging elastic pa siya, no? Ibig sabihin, um, yung pag elastic ang tawag sa kanya, kahit pag halimbawa tinanggal natin yung mismong loading, kaya pa niyang bumalik sa original shape niya, no? So dito sa portion na 'yon, kayang-kaya niya 'yon. Pero pagdating niya dito sa point na 'to, yung tinatawag natin elastic limit, pag lumampas pa siya doon, no? Hindi na niya kayang bumalik doon sa original shape niya. So halimbawa, nandito ka sa portion na 'to, which is beyond dun sa elastic limit natin. Pagkakameron ka na ng deformation. Okay? Or hindi na bumabalik. Kasi para di bang rubber band, pag hindi masyado malakas yung pagkakapul mo, um, nasa original shape pa din siya, di ba? Ngayon, pag hinatak mo siya ng sobrang lakas, makikita mo para siyang nagkakamero ng bewang o nagkakameron siya ng wave o curve pag nilapag nyo sa sahig or sa table. Kasi nag-elongate na siya. Ibig sabihin, yung elastic limit niya na-reach na niya o na lampasan na niya. Kaya hindi niya siya makabalik doon sa original state niya. Okay? So, ganun din dito sa steel natin. May portion siyang gano'n. Pag nandito na siya, meron na siyang deformation. Okay? Na uh, pag in-increase pa natin yung application ng loading natin and then nag-increase pa din yung strain niya, ano na niya yung yield point natin. Okay? And sa yield point is is yung point natin, we'll have again dito, no, after dito sa elastic limit natin, hindi siya go back ng na original shape niya. And then dito sa point na to, pagdating niya ng yield point is hindi na siya um, hindi na siya mag-elongate dito sa yield point, no? Um, or pagdating niya sa yield point, kahit hindi niya i-increase yung loading, magkakameron pa din siya ng strain, no? Napapansin niyo dito, kahit wala siyang very significant change in loading niya, nag-i-increase, no, yung strain natin dito. Okay? Na pagdating dito sa portion na to, papansin nyo, biglang nagkameron ng increase in stress, no? Kasi nagkakameron na tayo ng tinatawag na strain hardening or kailangan na ng mataas na loading para mag-elongate pa further yung mismong member natin, yung specimen natin. Kaya mangyayari, biglang nagkameron ng sudden increase ng stress dito para gumalaw yung strain natin. Okay? Na eventually, ma-reach natin yung ultimate strength point na to. Or, ito yung tinatawag natin tensile strength kanina. Okay? Ibig sabihin, ito yung pinaka maximum value ng stress na pwedeng makuha ng material natin na beyond this point, ang mangyayari na lang is no? Parang kung ibabalik natin dito sa tensile test natin, testing machine, puputok na siya or may mag-click na sound. And then, unti-unti na niyang tatanggalin yung loading hanggang ma-reach na yung kanyang rupture strength. Wherein, dito magbe-break na yung material natin. Okay? Kasi hindi na niya kayang ano, no? I-sustain pa yung loading. Na dito makita niyo, mayroon siyang tinatawag na actual na rupture strength kasi nga nag-i-increase pa din yung loading niya pero since parang dito pag reach na nung kanyang ultimate strength, nagre-relax o binabawasan na ng machine yung loading natin. Eventually, pupunta tayo sa rupture strength. Okay? So, Ayan. So yan yung sa ano natin, sa stressing curve, yung importance niya, no? Para maintindihan natin kung ano yung pagkakaiba nitong mga portions na to. Okay? So again, yung point na proportional limit, so ito yung applicable si Hooke's law. So ibig sabihin, directly proportional or linear yung relationship ng stress natin with our elongation. Okay? Then, yung kasunod, yung elastic limit. Sa elastic limit, dito in between ng dalawa, pwede pa siyang bumalik sa original shape niya. Pero beyond elastic limit, hindi na siya magkakameron na siya ng deformation. Hindi na siya babalik sa original shape niya. Then kapag nag-increase pa tayo ng counting load, darat tayo sa yield point natin. Wherein, uh, without any increase in loading, saka meron tayo ng appreciable elongation sa portion na to. Okay? And then dito, magpa-plastic na yung material natin. So, yun nga, ibig sabihin, kahit wala tayong loading, nagkaka-strain siya. Okay? And then eventually, may point siya dito na isa pa na mag-increase yung stress natin. Kasi hindi na siya nag-strain. Kaya si machine is mag-a-apply siya ng loading na eventually, ma-reach natin yung ultimate strength natin or yung pinaka-tensile strength ng material natin. Then ito yung re-record na pinakamataas na stress niya. Then after ma-record yun, mag-release ng loading si machine hanggang maabot niya si rupture strength. Wherein si rupture strength will be our breaking point. Okay? Or where our material breaks. Or dito, makikita natin nagne-necking siyang ganun, ano? Hanggang ano na siya, mag-detach from each other. Okay? Ayan. So, yun sa stress strain curve. And now, we go dun sa standard cross-sectional shapes for steel. Okay? So, in the design process, ang objective talaga natin on why we need to study steel, no, is to identify what section, yung cross-section yung gagamitin natin. I know in your practice sa architecture, meron kayong mga standard na ginagamit for depende no sa laki siguro no sa square meter, I'm not sure, pero kami as structural, uh, we need to select shapes na kung saan magkakamero ng advantage si client, no? Kung halimbawa meron tayong naisip na shape na wala naman sa available sa market, so it will be very costly na magpa-produce ng bagong shape. Kaya kailangan yung sa-select nating cross-section is off the shelf yung item natin or readily available sa market, no? So, pero pagdating kasi sa steel, kapag halimbawa massive talaga yung project, ang order talaga is nanggagaling pa sa overseas, no? Kaya hindi maiwasan talaga. Pero kung halimbawa mga for low-rise buildings lang yung project, may mga market tayo dito na nag-o-offer naman ng mga different cross-sectional shapes na pwede natin gamitin for construction. Okay, so what are these cross-sectional shapes? So these are the example. So let us discuss them one by one. So let us first discuss yung W shape. Okay, so W shape also called wide flange shape. Okay, so sabihin wide flange. So by the name itself, mas yung width nung flange is greater, no? In comparison with yung tatawag nating I-beam. Okay? May makikita kayo siguro dati na I-beam, ganyan yung itsura, no? Which is much shorter yung flange natin. So si wide flange, ganyan yung itsura. You have two parallel flanges, ito yon. Then separated by a single web, yung nasa gitna niya. Then the orientation of these elements is such that the cross-section has two axes of symmetry. So ano yung axis of symmetry niya? Ito yung y tsaka itong x na. So ibig sabihin, beyond this point, no, parehas ng distances, no, yung mga yan. So, ayan. So, paano siya basahin? So, halimbawa, you have W18 by 50. Yung first number, kasama yung W to designate na W shape siya. Yung 18 is, ito yung depth niya, no? Para sa depth niya, nung web. Okay? Nominal depth nung web. Okay? So, ito in inches yung example natin, no? Pero kung siya ay in metric, mas malaki yung mga sizes natin, ano? Pero in practice, pwedeng pagbalik na rin yung gamit nila, no? Kasi sa market minsan, parang pag bumibili tayo ng mga plywood, no? Gusto nila in board feet, yung 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 value o by feet, no? 8 feet by 6, ano? 6 by 8, gano'n. Yung sizes natin o yung kapag ano, ayan. So dito, ganun din, no? So in inches to. So in future discussions naman natin, identify naman natin kung metric or English yung unit. Okay? So dito yung nominal depth niya is 18. So yeah, ito yung nominal depth niya yun. Okay? Then 50 is yung weight niya. So kung gaano kabigat. So si steel na lalaman natin kung economical siya depende sa bigat, no? Kasi kilogram per meter ang presyohan po sa steel, no? Yung total weight ng steel ang pinag-uusapan. So, yung 50 na yon is yung weight in pounds per foot of length, no? Ayan. So, yan yung sa W shape. Next, we have yung S shape o yung American Standard shape na similar din siya doon sa W shape pero makikita nyo yung flange, no? Is much shorter. And then, ayan, yung pagbasa niya same din. Yung unang number pertains dun sa depth. And then yung 70 pertains dun sa kanyang weight in pounds per foot. Yan yung tinatawag nating IB before. No? Pero hindi ito masyado ginagamit sa Pilipinas. Ito usually yung ginagamit sa Pilipinas. No? Yung W shape. Okay? Next, we have the angle shape. So, si angles naman, available siya either equal leg or unequal leg versions, no? So parang self-explanatory, pag equal leg, um, same yung length nung each side. Pag unequal, much longer yung other side. Okay? And ang designation ni angel shape or mga angle shape, angle shape is kung ano yung length no nung one side times the length of the other side by yung thickness niya. Okay? So the three numbers are the lengths of each two legs measured from the corner o yung heel to toe and then thickness. Okay? So ibig sabihin to ay 6 by 6 o 6 inches by 6 inches by 33/4 inches yung thickness ng angle natin. Okay? For dito, meron tayong 6 by 4 by 5/8. Right? So, saan natin ginagamit si angle shapes? Usually sa trusses, no? Pag minsan sa ceiling, pag ginagamit natin sa ceiling, saan pa ba? Depende no sa application. Pero usually doon siya sa trusses mainly, no? Especially pag residential houses. Okay? We have yung C shape natin. Okay? This is patulad siya ng channel, no? Yan. American Standard Channel, C-shape. So, meron two flanges and a web with only one axis of symmetry. Yung axis of symmetry niya is ayan, only one lang daw. It carries a designation of C9 by 20. Wherein, yung similar siya sa W shape. Yung 9 is yung depth. And then yung 20 is yung weight niya. Okay? So, yung inside faces daw ng flanges are sloping. Kapag miscellaneous naman, the inside flanges are sloping kapag American Standard shape, no? Na channel. So, doon sa miscellaneous, yan. May nakalagay naman siya designation niya, miscellaneous o MC. Okay? So, sa channel, saan ginagamit? Usually, pwedeng sa stairs. Okay? Minsan, pag ginagawang rafter, pwede din. Okay? Or pag minsan, yung nilalagay natin sa wall para paglagyan ng pagkakasahan ng sa ceiling natin. Okay? Structural T. So, produce yan by cutting yung eye shape natin by half, no? Or mid-depth. Okay? So, this shape is sometimes referred as split T. Okay? So, kapag mabawa may nakita kayong WT, ST, or MT that pertains dun sa um, mid-depth ng mga shape natin na yun. Yung mid-depth ng wide flange, mid-depth ng S-shape, and mid-depth ng um, ano tong MT. So, dito sa miscellaneous na type ng T. Okay? So, paano naman siya? Ganun pa din. Yung, halimbawa, meron kang W shape na 36 by 210. Pag hinati mo siya, syempre yung depth mo, mahati sa dalawa. Kaya 18. Then yung, since kalahati yung babawasin mo, kalahati din yung mawawala sa weight niya. Kaya, naging 18 by 105. Okay? So, kapag yung shape does not fit dun sa classification ng W or S categories, M na yung tawag sa kanya, miscellaneous na. Okay? Then we also have other cross-sectional shapes, yung bars and plate natin. Bars can have circular, square, or rectangular cross-section. Depende sa width, no? So, kapag 8 inches or less, ano ba ang 8 inches? Kapag yung width natin is 200 mm or lesser, bar ang tawag sa kanya. Pero pag greater than 200 mm or 8 inches, plate na yung tawag natin sa kanya. No? So, yung mga ginagamit natin sa platform, sa catwalks, okay? Plate na yung tawag sa kanya. Okay, so the usual designation for both is the abbreviation PL for plate. Okay? Pero pwede din siyang gamitin for bar. Okay? Followed by the thickness in inches, width in inches, and the length in feet. So, ito yung thickness, width, and then yung kanyang length in feet and inches. So, ibig sabihin, 3/8 yung length, 5 width, yung width niya, and then yung haba niya is 3 feet and 21/2 or 11.5 inches. Although plates and bars are available in increment of 1/16 inch, it is customary to specify dimensions to the nearest 1/8 inch. Okay? Next na other cross-section shapes natin is yung steel pipe or mga HSS or short for hollow structural sections. So, si steel pipe is ginagamit syempre for depende, no? Halimbawa um, sa mga pipe racks. Okay? So, ang designation niya, pipe, uh, depende kung standard, extra strong, or double extra strong. Okay? And then, yung number indicated is yung diameter niya, nominal outer diameter in inches. Then, for hollow structural steel, yun yung mga shape natin. It can be produced as square, rectangular, or circular, or round. Okay? For pipe whose thicknesses do not match those in standard, extra strong or double extra strong categories, yung designation daw niya is the outer diameter and wall thickness in inches. So kapag halimbawa project specific yung size ng steel pipe na gagamitin, you can specify it as pipe, yung diameter by yung thickness in inches. So yung thickness niya na ito, and then yung outer diameter niya, no? Kung ano man yung value. Okay? So yan yung mga cross-sectional shapes natin. Now we go dun sa last portion ng lecture natin, which is yung advantages and disadvantages ng steel. So for the advantages of steel, structural steel, no? So we can siguro summarize it into 8 points, no? So syempre, advantage niya, number 1, high strength. Kasi nga, um, since malaki yung yield, yung capacity niya compared, yung tensile capacity niya, comparing with concrete, no? Especially concrete kasi si concrete is weak in tension pero strong in compression. Yung weight ng structure natin o yung size ng structure natin will be small. Okay? Pag steel ang ginamit natin. Also yung uniformity niya, yung property ng steel, hindi siya masyadong nagbabago habang tumatagal ang panahon, no? Unlike kay reinforced concrete, medyo erratic yung changes habang tumatagal. Okay? For elasticity, yung sa assumption natin na halimbawa yung ginagamit natin yung Hooke's law, almost the same, no? Or nare-retain niya yung property na yun. Hindi siya nagbabago over time, which is good for if na-design mo ng tama yung structure mo. Permanence, yung pag na-construct yung mga steel structure natin, kapag properly maintained sila, it will last for long years, no? Kung basta siya ay may maintenance siya lagi, nare-repaint natin yung surface niya, hindi siya magde-deteriorate agad. So mas matagal yung life ng structure natin. And kanina nga ductility, so kapag halimbawa extensive yung deformation natin, si steel can accommodate very large deformation without fracture, no? Or hindi siya nasisira agad-agad. Si toughness, kasi nga meron tayong si strength, high strength siya, tapos may ductility siya. Kaya tough din, we consider na yung toughness ni material, no? Ibig sabihin yung ability niya na mag-absorb ng energy is very greater, no, compared to other materials. Additions to existing structure, so mas madali silang ilagay kapag halimbawa may mga kailangan kang i-install na additional halimbawa floor. Halimbawa meron kang reinforced building na 2-story, and then hindi na kinakaya pag ni-recheck o ni-reanalyze yung structure. Hindi na kaya ng third floor na concrete din. Pero once you check na maging structural steel yung material, since mas magaan siya, mas madali siyang i-add as additional material or material ng third floor dun sa structure natin. And then other important advantage ni steel or yung miscellaneous advantage niya is mas madali siyang i-connect, no? Kung basta meron kang skilled workers to do that, yung magaling mag-weld or maglagay ng bolt. Si steel can also be prefabricated. Si steel is kapag you have the right equipment, madali yung erection niya o yung pag-construct niya. And then you can actually reshape yung steel natin depending on the necessity ng project, no? And then kapag halimbawa i-disassemble mo naman yung isang structure, you can reuse yung member na yon as long as na-check na pwedeng gamitin for other building. And then yung scrap value, syempre, kung hindi na siya reusable dun sa form niya, since steel pa din siya, ah, malaki pa din yung value niya, no? So hindi ka pa din ah, yung salvage value niya hindi masyadong nabawasan. Okay? So yan yung ilan sa mga advantages niya. However, kung may advantages siya, meron din siyang disadvantages syempre. And number one dyan siya, pinakauna dyan is corrosion. No? Kasi most steels are very susceptible to corrosion. Lalo na kapag malapit sa dagat yung structure or exposed lagi sa air. Kaya uh, kaya nangyayari para um, masalbat sa corrosion or ma-prevent yung corrosion is kailangan may periodic painting yung surface ng mismong steel natin. Okay? So, kailangan lagi siyang mini-maintain para hindi siya maging exposed sa mga unwanted or harmful na chemicals that would trigger yung corrosion dun sa ano niya. And once na nag-corrode siya, syempre, yung strength niya magle-lessen. Pag less yung strength, may possibility na mag-fail yung structure. Okay? Next is yung fireproofing cost. So, although yung uh, 'di ba sa steel, ginawa siya ay pinapadaan siya sa mainit na condition. Okay? Kung hindi fireproof yung material mo, syempre eventually may temperature or may limit yung temperature na kayang i-sustain yung steel. And without the proper fireproofing method na i-apply kay steel, possible na maapektuhan ulit yung strength ng mismong member natin. Okay? So, pwedeng mag-transmit din ng heat si steel, no? From one location to another, especially kung magkakadikit yung structure natin. Next is, meron siyang susceptibility to buckling. Kasi, di ba, since magaan nga siya, may tendency tayong mas longer yung spanning natin, mas matataas yung column natin. Na ang nangyayari naman doon, nagiging masyadong flexible naman. Yung masyadong slender yung member natin, na prone siya sa buckling, especially kapag uh, nag-increase yung compressive strength or compressive loading natin, may tendency siyang mag-buckle. No? So, ayun, yun yung isa sana. Then, fourth is yung fatigue or yung capacity ng body to absorb energy repeatedly. Kasi halimbawa sa earthquake, no? Syempre magsisway yung structure. So, yung back and forth na sway ng structure, minsan, nagiging undesirable kay steel yon kasi um, nagre-reverse yung stress sa kanya, no? May stress reversal na tinatawag. So, kaya pag hindi properly designed yung steel mo for fatigue, no? Kaya isa yun sa mga chine-check lagi kapag nagde-design ng steel, si fatigue. And um, ayun, so tendency niya kapag kailangan satisfy si fatigue, kailangan ipalakihin mo yung section, mas malaking section, mas mabigat. So, mas mabigat siya, mas malaki na yung cost niya. So, kaya siya naging disadvantage. Okay? Then last is yung brittle fracture, no? So, at some point, si steel may lose its ductility. And yung sudden fracture or yung sudden na pagputok nung pag pagbaklas ng mga steel, no, is possible to occur, especially kapag may stress concentration. So, kapag napanood niyo yung yung nangyayari sa although it's exaggerated, no, yung sa Final Destination, yung especially yung movie na yung sa bridge na nag-collapse, makikita niyo doon na yung mismong mga connections niya yung nagfi-feel, no? And nung nagkakameron ng stress concentration, nung nababawasan yung connection, syempre. Wala nang nagta-transmit nung mismong loading, kaya eventually, um, na-destroy yung structure. Okay? Which is caused by sudden stress concentration, which yield to brittle fracture. Okay? So, ayan. So, yan yung mga disadvantages sa structural steel. But, all in all, structural steel is a very good material, especially if your project um, has the means, no, to use structural steel. Mas maganda gamitin natin sa structural steel. Okay? So, this end our primer for structural steel. So, for questions, you may ask me dun sa GC natin for questions. And then, I hope um, you can study more yung stress and strain diagram. Kasi all of these are still included in your prelim exam. Okay? So, see you guys again on our next meeting, and thank you for watching this video.